Ayan. So once again, good afternoon to everyone. So if you haven't yet done so, please check the chat box ng Google Meet para sa ating link na attendance. So kindly fill that one up while I go over our agenda for this particular session. So today, we are going to have a continuation lang of what we weren't able to discuss in the last week na meeting. So this time, we're gonna talk about our Hess's Law. So today's agenda are as follows. So we just have our lesson proper. After we talked about our lesson, then we try to discuss our alternative assessment as well. And finally, we'll cap off this synchronous session with all other announcements that we have. So for today, in our LG 1.3, the Hess's Law, we are supposed to achieve the following target outcomes. So by the end of this learning guide module, the students should be able to 1. Apply stoichiometry calculations to thermochemical equations. 2. Apply Hess's law to determine the heat of the overall reaction of a system. And 3. Determine the heat of reaction from standard enthalpies of formation of reactants and products. So as you know, this is quarantine time. This is the time when we are stuck at home, just doing everything there without any access to the outside world, as much as we do normally anyway. So basically, right now, it's really quite a struggle to be able to keep ourselves in shape. Definitely, since we're just staying at home, the temptation is kain lang tayo ng kain, di ba? So basically, really keeping fit is a pretty big struggle for us. Now, don't you know, our fitness apps like MyFitnessPal, so it allows you to be able to compute how much energy is contained within our food. Now, how if our fitness apps are able to compute that one is basically fundamentally just by looking at the chemical composition of the foods that we are eating. So that is how it's able to give me, let's say, if I eat a burger, a slice of pizza, and my soda, so that's how I know na, in total, this could give me a total of 1,975 calories of energy, which I should be able to burn off if I do some exercises at home. So for today, what we're gonna be focusing on is how to be able to use the available data that we have to be able to determine ano ba ang delta H for any given reaction that we have. So that's where Hess's law comes in. Now later on today, we'll be doing a problem solving of a couple of problems. So what we're gonna do to be able to solve those problems, we're gonna utilize Google Jamboard. So for that one, I'm sending the link to you now sa chat box. So later on throughout this session, I highly encourage you to go to Google Jamboard so that you can solve with me the sample problems for Hess's law, so that we can at least try to practice this one as well. So again, the link could be found in the Google Meet chat box. So we've already delved in depth into the changes in energy our system undergoes whenever whenever a physical or chemical change is occurring. So now what we can do, we can actually utilize the given information na daan that's already tabulated, for instance, as well as the various chemical reactions that are known just so we can know ano bang delta H for any given reaction that we might be interested in without having to actually do the experiments themselves. So we do have these following properties ng heats of reaction. By the way, heat of reaction is just gonna mean the same thing as the enthalpy of reaction, delta H or Xn. So if you see sometimes na nakalagay sa problem is heat of reaction, it's just the same thing as if you have a different problem that is asking you for the enthalpy of reaction. So those two are just one and the same. So we observe the following properties regarding our delta H of the reaction. So number one, sabi dito, the heat of reaction depends on the physical state of the reactants and products. So in here, you have two examples of a chemical change. In here, you have solid water being turned into liquid water. And below it, you have gaseous na water vapor being turned into liquid water. Notice na just by changing the state of one of the chemical species that are involved, ang ating delta H nagbago ng value. So when you have a solid na water, the ice, turning into liquid water, delta H niya is very much different from the delta H if you have water vapor turning into liquid water. So the physical state of our reactants and products are very important and should always be specified in our thermochemical equation. Another property that we also observe as well is that the heat of reaction is an extensive property. Now, by extensive property, we mean to say na ang delta H or Xn, it is dependent on the amount of reactants that are consumed or the products being formed. So that's what you mean by extensive. Intensive, on the other hand, an intensive property is a property that does not change with the amount of substance. So an example of an extensive property aside from delta H or Xn would be the mass. Definitely, kung mas marami kang substance, mas malaki ang mass niya. Weight is also an example of an extensive property. Volume is also an example of extensive property. However, something like density, for instance, wherein you have the mass ng substance per volume niya, it's already an example of an intensive property. It doesn't matter if you have just one drop of water or all of the water within our Pacific Ocean, assuming na pure water yun. So, regardless of where that water comes from or gaano man siya karami, we expect that the density should always be the same. Now in here, you have an example that demonstrates our delta H or Xn as an extensive property. So in the first na equation that you have in here, you have the delta H or Xn equal to 6.01 kilojoule per mole. Now what we do now is we can just multiply both the reactants and the products by 2. You can do that, by the way, if you multiply both sides of the equation by one constant. It's actually understood na you're not really changing anything about the equation. Since basically what you've done on the left side, you've done with the right side. So by multiplying both sides of the equation by 2, we notice na actually ang delta H or Xn natin na doble din. From 6.01 kilojoule per mole, it is now 12.02 kilojoules per mole. So we can still apply the same logic, multiplying both sides of the equation by, let's say, 3. So delta HRXN will also change. Sige nga, can you guess for me, ano bang bagong value ng delta HRXN? If we multiply both sides ng thermochemical equation by 3. So any guesses how much this is?
$18.03 pa.
Okay, sino yan? Okay, Chelsea and Sandra also. So that's correct. So the original value, we just multiply it by 3. Thus giving us the new value of delta HRXN, which is now equal to 18.03. Oops, naglampas. So 3 times the 6.01 kilojoule per mole gives us 18.03 kilojoules per mole. So that goes to show na delta HRXN is definitely an extensive property. The more products and reactants that you have, mas malaki rin ang value ng delta HRXN. Another property ng heat of reaction that we observe is that the magnitude of the heat of reaction of a reverse process is equal to the forward, but it is opposite in sign. So you have in here yet another equation, a thermochemical equation for ice being converted into liquid water. Ang delta H niya dito is 6.01 kilojoule per mole. Now, obviously, you might want to do the opposite process. So you might want to start with liquid water na ilalagay natin sa freezer to be able to make our ice. So we might be interested to know, ano bang delta HRXN ng ating chemical change, na ating physical change na iyan? It turns out, for this one, ang value niya is the same as the first equation. The only difference here is that ang ating delta HRXN for this second thermochemical equation has the negative sign. So it has a negative sign because we just simply took the reverse of the original na thermochemical equation. And finally, and very importantly for us, if we're gonna discover some new chemical na process whose enthalpies have not yet been discovered, is number 4. The heat of reactions from all of the known reactions can all be added together. Now, this property of heat of reactions is what you call as the Hess's law of heat summation. Now, Hess's law states that if a chemical reaction can be carried out in 2 or more steps, the overall heat of reaction is the sum of the heat of reactions for all the individual steps. So for us to better appreciate what this means, so now let's try to look at this particular example. This solved example that we have over here. Okay, naglampas lang. So let me just edit it very quickly since it's overlapping. So moving away from talk of food, so now this time, let's talk about something that is a little more industrial based. So when you are now trying to convert your methanol is one type of alcohol, into formaldehyde and hydrogen, we're able to have the following chemical equation sa pinakataas. So this one over here. So this is a way for us to generate hydrogen gas that can then be used as a fuel for our engines. Now, experiments were performed to determine the heat of combustion of the methanol, the formaldehyde, and hydrogen. So you have the three thermochemical equations that are shown in here. Again, still overlapping. Why? So in the combustion, we have the following data that is given in here. So for methanol, when it is burned in the presence of oxygen, or combusted in other words, you have this value of delta HRXN. For our formaldehyde, combusted gives us the following value, and same with our hydrogen as well, once it is combusted to form water. So using these data that we have, itong tatlong thermochemical equations that we have, we are now asked to determine what is the delta HRXN for the conversion of methanol to formaldehyde and hydrogen. That is to say, itong ating chemical process that is described by this equation at the top. Okay. So hindi makita ang screen. Sorry about that one. Okay, pa-verify lang ako guys if kita na ba ang screen.
Nakita na po, sir.
Okay, thank you so much. Sorry late ko na napansin, Sandra and Kauri. So what we have is the following. So first, we can just summarize all the given information we had earlier. So first, we have the following rules that were laid out earlier, the 4 rules that we had that we can use to be able to compute delta HRXN. So we just put it in there sa taas para may guide lang tayo. We also have the given data that are all summarized in here as well for our reference as well. And finally, in blue is the particular na chemical process whose delta H that we are looking for. So what we're gonna do is as follows. So we just look at our data in here and then we notice the following. So una-una, the first na thermochemical equation that we have in here has the CH3OH, which corresponds to this one in the final na equation that we're supposed to be getting. Ang kaibahan lang nito, the one in blue, and our first thermochemical equation is that the CH3OH here is multiplied by 2. So what we're gonna do is, we'll be using our rule number 2 earlier, namely, that the heat of reaction is an extensive property. So copy lang natin itong ating first na thermochemical equation. And then, para lang maging same ito siya as the one that we target to be able to get at the end of the solving, we can just divide everything by 2, as shown in here. So that when you divide everything by 2, ang CH3OH here now becomes CH3OH na lamang. The 3 na coefficient ng oxygen divided by 2 gives us 3 halves. 2CO2 divided by 2 gives us 1 CO2 na lamang. And 4 water divided by 2 gives us 2 water na gas. And delta H is also the same. So we just have this value over here, the negative 1353, and we divide it by 2 as well, which is how we were able to get negative 676.5 kilojoule. So doing that one, this new thermochemical equation that we have over here already has the CH3OH that we need para matumbok natin itong target na equation. Now moving on to the next one, we can look at H2CO next. The H2CO in here has a coefficient of 1. So from our data, we're given a thermochemical equation na may H2CO din. It's the second one that we have over here sa ating right side. However, ang difference lang nito between this one from our data and from our target equation is that H2CO in our target equation is nasa product side. Whereas in here, the H2CO is on the reactant side. So gagawin natin, again, i-copy lang natin itong second thermochemical equation that we have. Okay, sa H2 pala ako nagtingin, sorry. H2 pa pala aking gitype, sorry. So for the H2 pala, ang ating gagawin pa first. But anyway, you can do it in any order naman. So copying the data para sa hydrogen, which is the following. And then we try to do the same thing as what we've done earlier. So gusto natin na, from a coefficient of 2 dito, gusto natin na coefficient of 1 na lamang. So again, we divide everything here by 1/2. So doing that gives us a new thermochemical equation. So in here, so like we did earlier, the 2 hydrogen divided by 2 gives us 1 na lamang. The oxygen divided by 2 gives us a coefficient of 1/2. And our 2 water divided by 2 gives us only 1 water molecule in the gaseous state. And ang delta H Rxn niya is also done the same. We just simply divide this one over here by 2. So negative 484 kilojoules, we divide it by 2 to give us this one over here. So itong dalawa ngayon, this one in here that we have done earlier, and this one as well that we have just recently done, we're gonna keep it for further use later on. So ngayon, balik tayo na magtingin kay H2CO. So notice na ang gagawin lang natin dito is, parang ito lang naman siya, the second one na given sa ating data. But basically, this one is on the reactant side, while our target has the H2CO on the product side. So what are we gonna do with this one? So again, we're gonna use our rule number 3. In the rule number 3, what we're gonna do is we'll just copy the thermochemical equation that we have as such. And then applying our rule number 3, we're gonna take the reverse of this one. So meaning, all of the products that we have in here, we'll just rewrite it as the product, as the reactants. And ito, the H2CO and the oxygen, will just bring it over to the product side. So getting the reverse reaction gives us a new thermochemical equation na naman. So we just basically flipped over the positions ng reactants and products of the original thermochemical equation. And when we do that, when we take the reverse of a thermochemical equation, ang delta HRXN natin, we just simply multiply it by -1. So in our original data, the delta HRXN is equal to -520. -520 times -1, since we did a reverse operation, gives us the new value ng delta HRXN, which is gonna be 520 kilojoules. And kung babalik tayo dito sa previous na slide, so we're gonna do the same thing as what we've done with H2CO. So meron na nga tayong H2 gas, which is having a coefficient of 1, kaso lang, nasa maling position siya. This hydrogen gas is on the reactant side, while in our target, we want our hydrogen to be on the product side. So we'll just have to get the inverse. So to do that, we'll just have to flip everything over. Si hydrogen gas, ililipat natin dito sa left side. The water rather, sorry. The gaseous water will just transfer it to the reactant side. And our hydrogen and oxygen will transfer it to the right side. So at this point, let me ask for your guesses. If i-reverse natin itong equation na ito, so what will be the new value of delta HRXN? So any guesses what that value will be? Okay, so Rad, Vea, Ivan, Jamir, and Vince all have their answers. So let's see what the correct answer is. Chelsea, Kent, and Kauri as well. Pag ni-reverse natin ito siya, this is what we're gonna get. So copy lang natin yung ating thermochemical equation from earlier. Getting the reverse gives us this new value of delta HRXN, which is, as what you've stated sa chat box, it's equal to 242 kilojoules. So at this point, we're actually now ready to use Hess's law. We've already arranged all of the substances na nasa target equation in their correct positions. So CH3OH, tama ng kanyang coefficient, nasa tamang side rin siya earlier. H2CO, so pareho lang rin, it's already on the right side of the equation. And same with our hydrogen as well. So the hydrogen, it's now already on the correct side. So this is where our rule number 4 comes in. So all we need to do is we just copy all of the thermochemical equations that we made up. So starting with the first one that we had, copying this one over here that we've made, so we now get the following. And copying as well all of the reverse na thermochemical equations, we have then the following values as well. Now, all we need to do, according to rule number 4, is we just sum up all of the reactants and all of the products together. So summing them all up, we get the following. Now in here, we can still simplify this one further because if you notice carefully, you have, for instance, 2 water na gas in the reactant side ng sum. And on the product side, meron ka ring two water na gas as well. So these two waters can actually cancel out one another. So what's gonna happen is the following. So the oxygens are gonna be the first that we cancel out. May 3 halves ka sa left side ng arrow. Sa right side ng arrow, meron ka ring 3 halves na oxygen. So that will cancel out. Same rin with the water as well. And finally, our carbon dioxide gas will also just actually cancel out as well. Since CO2 is found on the left side and also on the right side. So kung titingnan mo ano nilang natira, it actually gives us the target equation that we have. Meron na lamang tayong CH3OH gas on the reactant side. And for the product side, we have H2CO gas and hydrogen gas as well. So once that we're sure na the sum is already the same as our target, we can now safely add all of the delta H Rxns together. So adding them all up, we get the value ng delta H Rxn, which is 86 kilojoules. So that is how you now use Hess's law to be able to determine how much heat is gonna be involved in a reaction whose heat is not previously known pa. So all you need to do, you just have to look at the data of all the known na thermochemical equations, manipulate them so that you're able to get in turn from all of the manipulations ang target na equation. And from the Hess's law, we just simply have to add up ano bang delta H Rxns that we have. So that's how we get this answer na 86 kilojoules. So this gives us a powerful tool to be able to get delta H without actually having to do the experiments. All we need to do, we just have to base it on the pre-existing na data.
Sir.
Yes, please.
Asa gikan tong 3.5 ay 3 halves dito sa second equation.
Okay,
Ay, combine mo tong second ug third.
3 halves na oxygen.
Oo. Asa gikan?
Balik tayo. So it comes from in here. Kung nag-umpisa tayo, di ba, with this one na galing sa ating given na data. So we copy now this one over here. So pag copy natin, we now get this one that we have shown on the screen. But for the meantime, this is not yet usable. Bakit? It's because ang target natin has a coefficient of 1. While our data, the CH3OH has a coefficient of 2. So anong gagawin natin? Para lang maging equal ang coefficients nitong CH3OH, we divide everything by 2. So when you divide everything by 2 in here, that's how you're able to get the 3 halves na oxygen. 2 divided by 2 gives us 1 na lamang, same as what we're supposed to get sa target. 3 divided by 2 gives us 3 halves. 2 divided by 2 gives us 1. 4 divided by 2 gives us the 2 water. Okay, so does that answer your question?
Ay, katong balik ko dito sa answer tong sa fourth niya katong ikaupat na nga ano katong add na jud.
Sa rule number 4 you mean?
Opo.
Okay.
Sige, I mean, dira gud sa baba, sir. Karang sa H2CO tapos 3 halves O2. Asa gikan ng 3 halves dira, sir?
Okay, good question. So ito, meron kang oxygen. So oxygen dito has a coefficient of 1. And sa equation na naman na ito, the third one that I'm pointing at right now, may coefficient siya na 1 half. 1 plus 1 half gives me 3 halves.
So gi-combine lang to nimo tong second ug third
Mm-mm.
nga. Okay.
So lahat ng oxygen, gipang-add ko lang sila together. 1 oxygen plus 1 half oxygen gives me 3 halves oxygen.
Ay, so i-combine ang reactant sa reactants nga tanan tapos ang product sa products nga tanan.
Yes. It's kind of like if you have an algebraic equation, you have to add all the like terms together. So in here, meron kang oxygen na 1, i-add mo rin siya sa kapwa niya na oxygen pa rin. So 1 plus 1 half, that's how we were able to get the 3 halves over here.
Sige sir, thank you, thank you.
Okay, thank you, Paul. Other questions or clarifications that you want for this example? Any other parts that you want me to go over or clarify further to you?
Sir,
Yes, please.
may tanong lang ako. Yung sa pagkuha mo ng change in enthalpy na ng combined na talaga na chemical equations, gi-minus mo lang yung tatlong
Okay,
like
Bea,
itong,
what you do is you have to add them. So you can actually get your calculator if you want to double check this one. So negative 676.5 plus 520 plus 242. So pag i-total natin yan, let me fast forward. Negative 676.5 plus 520 plus 242 gives me a sum of 86 kilojoule.
okay po sir. Thank you po sir.
Okay, thank you, Bea, for that one. Other questions? Anyone?
Sir, may question lang po ako.
Yes, please, go ahead.
If i-add na po sila, hindi na po parang worry po, dalawa po yung compound sa reactants or sa products po na side. Pwede yan sila mag-interchange ng position, sir?
What do you mean na mag-interchange?
Parang, I mean yung kare sa reactants side po, may dalawa pong i-add para makuha yung product po. Pwede po sila magkapalit po ng like yun dun po sa kare wait lang. Kare po yung CH3OH plus yung kare po yung dyan po yung sa una po na chemical equation, yung 3 halves tsaka 3 halves na O2, pwede yan silang magkapalit po, sir. Yung
Okay, so i-interchange ko lang pagsulat.
parang
You mean?
pwede yan siya, sir.
Oh, pwede naman siya, Chelsea. So
Okay,
basically,
thank you po.
inuna ko lang si CH3OH because siya kasi ang target ko eh. In my target equation, what I want is I should be able to get CH3OH. Kaya siya talagang inuna ko. That's why I want to highlight this one. But in any case, pwede naman baliktad. You can just write 3 halves O2 plus CH3OH. So pwede naman natin gawin iyon.
Okay po, sir. Thank you po.
Okay, thank you, Chelsea. Other questions?
Sir,
Yes, please.
about po sa formative 1.2 po, nag-iiba mo po yung questions?
Okay. Later na lang yung Kauri ha. Let's just keep it to the other announcements na portion. I did have a lot of questions with that one. So, let's just keep it later na lang. Kaya para at least we can just focus muna on the lesson proper muna.
Okay po, sir.
Okay, thank you, Kauri. Other questions pa regarding this example? Questions or clarifications? Violent reactions?
Wala na po, sir.
Okay, thank you, Ken. Sige. Using our data from the thermochemical equations, we can use Hess's law to calculate delta H Rxn. Now, another common data that we're given would be our heats of formation. So now we have to define a couple of things. So normally, ang enthalpies ng reaction natin, they are measured at 25 degrees Celsius and at 180 m of pressure. So when that happens, pag ang temperature is 25 degrees and the pressure is 180 m, you have what is called as the standard enthalpy. And for us to know na we're dealing with standard enthalpy, naglalagay tayo ng degree na symbol. So delta H degree tells us na we have an enthalpy measured at 25 degrees and 180 m. Now the standard heat of formation, guys, this is the enthalpy change that is associated with the formation of 1 mole of a compound from its elements in their standard states. Now, very important for us to remember, if you're talking about the elemental forms ng ating mga molecules or ating elements rather, delta HF in its most stable form at the standard state na 25 degrees and 180 m is always gonna be equal to 0. So you have in here a very scary looking na equation right over here. But don't worry, this is actually a very simple thing to use in practice. So what it basically says is, another way that we can use Hess's law is that the heat of reaction can be computed from the values of the delta H formation of the reactants and the products. So that if you're given the balanced overall chemical reaction, you can now use this equation over here. So it might look a little bit intimidating, but
Hi, sir.
actually using them is a little bit simple lang naman.
Pwede pakibalik lang ka, dali lang. Sa ano?
Okay.
Okay. Sige, sir. Thank you.
Sige. So please feel free to just stop me or ask me to go back if you have something that you want to see again. So this time, let's now use Hess's law, but this time using the heats of formation. So in here, you have example number 2. So you have here carbon dioxide. So it's a very common na byproduct. It's also a thing that we are very alarmed by in our state right now, since basically it contributes to greenhouse gases rather. But it turns out that this carbon dioxide, you can actually react it with hydrogen gas to be able to form methane gas. Methane is particularly important to us because it is a fuel that we can use, that we can burn to be able to generate energy. So in this particular na target na equation, we now have the given information. So the standard heats of formation in kilojoules per mole for the reactants and products are the following. Carbon dioxide, it's negative 394 kilojoule per mole. CH4, that's negative 74.9. Hydrogen gas has a value of 0. And water na gas has a value of negative 241.8. So right away, we can notice na si hydrogen ang naiiba dito because siya is automatically 0. Actually, this is common for all of the elements. So let's say you have your oxygen gas at 25 degrees and 180 m. Oxygen is commonly found in the environment at 25 degrees and 180 m as a gas. So oxygen gas, tulad ni hydrogen gas, at the standard state is gonna have a heat of formation equal to 0. So whatever is the state of that element that you find in nature, we always expect na ang heat of formation niya would be 0 at the standard state.
Ay sir, given na nadaan ang iyang standard formation.
Okay, good question. So this one, so in a problem, you might be given this one, or you might be directed to look at our textbook. So remember that in our K-Hub, I already posted a link para sa ating book by Silverberg. So we're gonna use our Silverberg also to look up the data for this one. But more on that one later. We'll just go over Silverberg pa rin so that you can see saan ba nakalista itong mga values na ito. Okay? Sige, so now let's try to use the given information. So we have the target equation that we have and the data for the heats of formation are also given here. So what we're gonna do is we now use Hess's law to compute the delta H. So delta H of the reaction at standard state is given by this equation over here. Now what we're gonna do is the following. So una, we just look at our products. Our CH4, for instance, has a coefficient of 1. That's why I write 1 mole in here. So 1 mole ito times, ano ba ang heat of formation ni CH4? CH4 has a heat of formation of negative 74.9 kilojoule per mole. So that's 1 mole times negative 74.9 kilojoule per mole. Plus, we also look at the other product. So that is water. Ang coefficient niya is 2. So we just have to write 2 moles. Times, para sa water, ang heat of formation niya is negative 241.8. So I copy it over here. So we add them together, ang lahat ng products, and then separately, we can add up all of the terms para sa ating reactants. So sa CO2, same process pa rin. We just have to look at the coefficient ng CO2, which is 1 in here. So that's 1 mole times the heat of formation ng CO2 na negative 394. Plus, for the hydrogen, it has a coefficient of 4 moles. That's why I write it here as such. Times heat of formation ni hydrogen na 0. So adding up all of the products together minus the sum for all of the reactants will then give me the delta H for this one. So you can use your calculator to verify this one further. But if I simplify this one, it turns out na delta H ng reaction is negative 164 kilojoule. So this is yet another way that we can compute delta H for the reaction using our Hess's law, provided na alam natin ang heat of formation niya. Okay? So that is our example number 2. So for example number 2, are there any questions ba on how we solve this one? Questions, clarifications? Na-follow lang how we use Hess's law for the heats of formation.
Yes po, sir.
Okay, thank you so much. So basically, we just had a very complicated looking equation. But actually, the way that we use it, it's really quite simple lang naman. So that is how we can use Hess's law in two ways. If given ka ng mga thermochemical equations, we just use the same process as what we've done sa example 1. And if available ang heats of formation, you can also do your similar process to example number 2. So it really is only a matter of ano bang data ang available sa iyo na pwede nating magamit. What we're gonna do is we'll try to now solve this one together. So this time, you have the following. Two gaseous pollutants that form in auto exhaust are carbon monoxide and nitrogen oxide. An environmental chemist is studying ways to convert them to less harmful gases through the following equation. So given the following information below, the equations A and B, so we're now tasked to calculate the unknown delta H. So what we're gonna do, guys, so that we can solve this one together, so please use the Jamboard link that I sent sa ating chat box. So I'm resending it to you now. And together, let's try to solve our problem in here. So kindly go over to your Jamboard so we can try to solve this one together. So we already have a couple of people who have joined the Jamboard. So let's also wait for the others na so they can also participate as well. So maybe the others would want to join as well. So we still have 15 people. So we're still waiting on the rest of the class to join the Jamboard. So while we wait for the others, let me just write the target equation natin. Ang target natin na equation here is to be able to get the following. So, drawing. Okay. It was working earlier. Bakit hindi ka mag-draw? Draw! Come on! Mag-draw ka for me. Okay, ang pangit ng ano. I already had my tablet prepared for this one, kaso ayaw niya. But anyway, pagtiisan na lang, fail ang aking ano. So let me write down the target equation. So what we're supposed to do is, we're supposed to find the delta H for this one. So the struggle is really real when you don't have a mouse. But anyway, we'll make it work. We'll just have to find a way na lang. So in here, we have the following given information. So looking at equation letter A, so can you suggest what we're supposed to do for equation A? Para lang ma-achieve natin itong CO on the reactant side. So is there anything that we need to do para sa equation A? It's so sad. It won't draw. Okay. Can I hear anybody who'd like to share? So what do we do para meron tayong CO gas sa ating final na equation? So basing on our equation A and equation B, so what do we need to do first? Para meron lang tayong CO.
Wala na siya.
Okay? Sige, so parang wala naman tayong gagawin ano. All we need to do is we just simply copy lang naman. So maybe someone would like to write for me, ano bang ilalagay natin dito? So what do we do with equation A? So kindly just write it here sa ating space sa baba. You can just copy this one. You can do operations with it. So whatever you think para lang magkaroon tayo ng CO gas. Can somebody please write for me itong equation A sa ating Jamboard? Okay, sige na nga. Ako na nagagawa. Yes,
Sir?
please.
View only lang daw po yung Jamboard. Di daw po makasulat yung iba.
Ay, okay. Kaya pala hindi ako makasulat sa aking tablet. Okay. So at least I know the source of the fail. Anyway, sige, dictate nyo na lang guys ano aking isusulat dito. So nakasabi naman kanina na we just have to copy lang whatever is the equation A that we have. So copy ko lang sa equation A. So that gives me the following. So the bloopers and the struggles of online learning. Just imagine how easy this would be to have the entire class participate if meron talaga tayong whiteboard, if we were actually doing this in the classroom. So sige na lang, it is what it is. We'll just have to make the best of it. So just by copying the CO, or rather the equation A, so we already have the CO gas in our target equation. Now this time, what we're gonna focus on is C and O gas. So I think we should be using equation B this time. So can anybody suggest to me, ano bang gagawin natin kay equation B? Para lang magkaroon tayo ng 1NO gas in the reactant side.
I-inverse, sir.
Okay, so Phil says na i-reverse. Almer also says the same. So you need to reverse the equation B. So kung i-reverse ko siya, I have from equation B the following. So struggle to have to write this one down. Nag-charge pa ako ng tablet ko and all, thinking that I would be able to use it, pero hindi pala. So taking the reverse, ang delta H niya magbabago. So can you tell me what is the new value of delta H for equation B? So how much is the new value ni delta H after ko gi-reverse si equation B?
Negative 180.6 kJ, sir.
Okay, thank you so much. So that's negative 180.6 kilojoules. This is the ugliest my handwriting has ever been. And also the most difficult thing to write. Pero sige na lang. Okay, so we already have this one. So by doing this, ang NO nasa tamang lugar na siya. So it's already on the reactant side. Kaso, the equation B na NO has a coefficient of 2. So this tells us na there's still something we need to do aside from reversing. So can anybody tell me what I need to do as well sa equation B?
Multiply by 1/2, sir.
Okay, thank you, Bea. Jamir as well. So we can multiply everything sa equation B by 1/2. By doing so what we're gonna get is the following. Para hindi na masyado nakakapagod na i-sulat ito using the trackpad. So let me just delete na lang or erase. So 2 divided by 2 gives me 1 NO na lamang. And as for the nitrogen, so 1 nitrogen times 1/2 gives me 1/2 N2. Same rin kay oxygen. So 1 oxygen times 1/2 gives me 1/2 O2. And for the delta H, we also have to divide this one over here by 2. So can you please compute for me, ano bang value nito once it's divided by 2? Okay, thank you, Vince, Sandra, Vea. So we have negative 90.3. Again, please don't forget to write the unit of your delta H. So just the value only, it will not be accepted as a correct answer. So struggle again to erase the things. We have negative 90.3. So now we have the carbon monoxide and the nitrogen monoxide at the right portions or the right places sa ating target na equation. So I think we're now ready to sum everything up. So summing everything up, we have the following. So carbon monoxide, wala siyang same na term sa reactant side. So we just copy it down. Ang NO natin, also the same. So wala siyang katulad sa reactant side. So we just copy that down as well. Plus also our 1/2 oxygen. So copying that down, we have the following terms on the reactant side. Now for the product side, we have carbon dioxide. So copy ko lang yan. So that's CO2 gas plus the 1/2 nitrogen. Wala siyang katulad sa reactant, sa product side pa rin. So I just simply copy it without adding anything. So I have 1/2 N2 plus, finally, we have 1/2 oxygen na nasa product side. Now, if you look carefully, ang ating oxygen is present both in the reactant side and on the product side. So the 1/2 oxygen, magka-cancel out lang yan. So canceling that out, what is left now is our target equation over here. So now, since we've already got our target equation, we can confidently add together the negative 283 plus the negative 90.3 kilojoule. So can you please compute for me how much ang ating delta H for this reaction? So kindly add delta HA and the delta H in blue over here. So how much will this be? So Sandra with her answer, which is negative 373 point 3 kilojoules. Just so that we can see clearly anong final answer, we make it a habit to box or encircle our final answer. So delta H is as follows. So that's how we use Hess's law for our, when we have the thermochemical equations as the given data. So for this example, are there any questions ba? Questions or clarifications? Violent reactions?
Wala na po, sir.
Okay. Thank you, Ken. So this time, so hopefully this one doesn't need a lot of writing on my part. So we have here our nitric acid. So nitric acid, whose worldwide annual production is nearly 10 billion kilograms, is used to make many products, including fertilizers, dyes, and explosives. The first step in the production process is the oxidation of ammonia, whose chemical equation is given below. So given the heats of formation na values, or the delta HF, so kindly compute for me Ano bang delta H for this reaction? So the values are shown on the right. So kindly please use your calculator. So please compute that one for me. Then please dictate ano ba ang ating solution for this one. So before you compute, siguro better na i-dictate muna natin. So delta H is all of the products minus all of the reactants. So start tayo kay NO. So can you tell me what I should write in here para kay NO? So for NO, ano bang coefficient niya?
Coefficient po, sir.
Yes, please.
4 po.
Okay, so I write 4 moles para kay NO times ano ba ang heat of formation ni NO? Based on our table over here.
90.3 po.
Okay, thank you. 90.3. Ang unit nito is kilojoule per mole. So that takes care of one product. So the other product that we have is oxygen. So we can write the a similar thing as well para kay oxygen. So plus, ano bang coefficient ni oxygen here?
5 po.
So that's 5 moles oxygen times the heat of formation ni oxygen, which is how much?
0 po.
Okay, thank you. So that takes care of all of the products. Minus the summation of all the reactants. Ang reactants natin are NH3. So kindly dictate to me, what should I write for NH3?
4 moles times negative 45.9 kilojoules per mole.
Okay, negative 45.9.
Sir, nga nung nagbalin nun sila.
Okay, I'm struggling to write it down. Ang formula natin is the products minus the reactants. So what are your products? Your products are the NO gas. So itong NO ngayon plus our, bakit nga ba? Okay, I'm really stressed with how difficult it is to write using the trackpad. So I apologize for that one. This is 6 moles of water. So the stress is so real with the bloopers ng ating synchronous classes. For water, water na gas, take note of the gaseous state niya. Since in here you can see na may dalawang listing for water. You have the water gas and the water liquid. And both of them have very different values. Which is why it's so important na we have to specify what state our chemical species are in. So for the water gas, that is negative 241.8.
Sir,
Yes, go ahead.
may tanong ako, sir. Bakit dyan siya sa may kasama po ng values ng 4 and H3 nilagay yung sa water po?
Okay, ang water natin is products kasi. So una natin isusulat is all of the products. This is for the NO here. And this one is for the water.
Okay po, sir. Thank you po.
Okay, once you're done writing the products, saka pala natin isusulat si reactants. So here is where your NH3 comes in and the oxygen as well. So kindly please compute for me. So how much will this one be equal to? Please excuse the ugly handwriting. It's very difficult to write using a trackpad. So how much will be our delta H in here? So anyone who've already computed the value of delta H for this one? So Vea has her answer. So how about the rest? Okay, Vince also has the same answer. Same with Ivan. So in here, the final answer is negative 906 kilojoule per mole. Kilojoule lang rather, sorry. So notice na ang unit ng mole will cancel out in here. And all that will be left for the unit is kilojoules na lamang. So that's the reason why in our final answer, we only have the unit of kilojoules. So Chelsea also got the correct answer for this one. So for problem number 4, so are there any questions ba on how we were able to answer this one? Questions, clarifications, violent reactions?
Wala na po, sir.
Wala na po.
Okay, thank you. Sige, so balik tayo sa ating PowerPoint. So in our problem number 4, the value of the delta H formation is given. And in any case, in our textbook, we can always refer to it for more values of the heats of formation. So you can find the heats of formation all in the appendix C of our textbook. So I highly suggest if you don't have the copy ng textbook pa, to just download it sa K-Hub and go over appendix C for the more complete list of our heats of formation. So in summary, we have the following. So our heat of reaction depends on the physical state of the reactants and products. The heat of reaction is an extensive property. The magnitude of the heat of reaction of a reverse process is equal to the forward but opposite in sign, and Hess's law states that the heat of the reactions can be added. So that takes care of our lesson proper. So another thing that I'd also like to discuss with you guys is our alternative assessment. If you checked K-Hub, you might have seen in there that there is an alternative assessment. Since we don't have a laboratory that we can do at home naman, so what we're gonna do is we'll just do a virtual laboratory. But basically, it's still gonna be the same. We're gonna do our virtual lab in groups. So what I'd like you to do, so as a bit of an assignment, I'd like you to group yourselves into 5 people. So 5 people in a group, then just send me the list of your group mates sa ating GC. So that we now have our grouping. So among your group, kindly please assign who will be the leader, who will be in charge of submitting the answered worksheet for the entire group. So take note na maski si group leader lang ang magsasubmit, ang ating worksheet is still gonna be a group effort. So let me open up the activity right now. So we have the following. So very quickly, let's go over the virtual na lab natin for our Chem. So by the way, this copy ng ating Word document is already available in our K-Hub. So you can just download it. Try to assign each person what parts of the worksheet they're gonna answer. And you can just collate all together all of your answers. Para later on, the group leader will submit for the entire group. So this is your worksheet. So on the worksheet, kindly list down the names of all your members sa group, your section. Under the date assigned, write the date today and the date submitted, which will be next week, Monday. So for the procedure, you're supposed to go to this link over here for the actual activity. And then you all have to follow the procedures that are listed in here so that you can do the actual na virtual activity. As you're doing the activity, so please enter your data in the data table that we have. Notice na meron lang akong 3 na columns in this one. So you can just add more columns. So since we have 5 people in our group, so there should be 5 data that we have. 1 column for student 1, 1 column for student 2, 1 column for student 3, and so on until all members of the group have their own individual data as proof that they have actually performed the virtual lab themselves. And once you already have your data, so you can now answer your discussion questions. There are 5 questions all in all. So what you can do, just to lighten the load, you can just discuss amongst yourselves, sino ba mag-a-answer na number 1, sino sa number 2, number 3, and so on. Para naman hindi masyadong mabigat ang paggawa ng activity na ito. And finally, if you're gonna be using references, please be sure to use the APA citation format. In case that you forgot how to do the APA citation, I've also included a link here to guide you on how to do the proper APA citation format. So please also remember to list your references in alphabetical order on the space below this one. So that's gonna be our activity, our alternative assessment. So you'll do it by group, and that will be submitted by your group leader next week on Monday. So also to ensure that all members of the group are gonna participate, na hindi lang si group leader ang a-answer ng lahat, and kawawa siya in the process. So you will also be asked to rate your members ng grupo so that at least I know naman sino ang nag-participate and sino ang wala talaga ginawa in the making of this assessment. So that's basically it for our alternative assessment. Are there any questions regarding this one?
Sir, aside from that, sir, may formative pa ba, sir? Or yan na yung activity namin for the week?
Yes, Kauri. Yung iyong question kanina na nag-iba yung question sa formative, actually, that's the formative na para this week talaga dapat. So you now have 2 activities to do. The assessment na formative. So you have formative assessment and also this alternative assessment that you will be doing by group.
When po, same lang po sila deadline, dalawa, sir. Yung formative and yung alternative po.
Yes, so both of them, they are both due on Monday next week. So again, to be sure na at least hindi naman sobrang bigat nitong pinapagawa, so just coordinate amongst yourselves. Sino ba ang mag-answer na number 1? Sino sa number 2, sa number 3, and so on. So basically, it all boils down to gagawin mo lang yung simulation. So you'll just have to do a very quick run. Fill up mo lang itong data and i-answer mo lang yung aside mo na question. Easy as that. So hopefully, that way, hindi masyadong burdensome on your part.
Ano pala yung ginawa namin na last week po, sir, na 1.2 po? Salip, like, graded po rin ba yun? Kasi like, same lang po yung submission ng 1.2 and yung 1.3. Yung 1.3 po, di ba yung nag-iba ng question?
Okay. Sige, so we're going to the other na parts, other announcement. So I had an error in copying and pasting the assignments for this one. So basically last week, so you had numbers 1 to 4, di ba? If you recall. And I asked you, since di tayo natapos na discuss sa LG 1.3 last time, numbers 1 and 2 lang ang sasagutan nyo. So this time, ang sasagutan nyo is yung numbers 3 and 4 from last week. So if you answered already from last week, all you need to do is i-submit mo na lamang si numbers 3 and 4 para sa ating formative assessment.
Para yan sa 1.3, ay, na ano sir, iba na yung sa 1.2.
Okay, para sa 1.3 na yun, the numbers 3 and 4, they count for the formative assessment ni LG 1.3. The numbers 1 and 2, yun lang siyang intended para kay LG 1.2.
Sir, ano lang sir, tanong lang sir, kasi yung nalagay na questions doon sa 1.2 sir, sa pag-open po na review. Numbers 3 and 4 na ata yung nalagay doon.
Yes. So there were a couple of people also who raised that concern. Again, namali lang ako ng copy and paste. Again, I apologize for that one. Ang LG 1.2 dapat is numbers 1 and 2. So for that one, sige na lang, I'll just give you further updates regarding this one. Just
Okay.
so we can already end this session now. So I'll just chat you na lang sa chat box.
Okay po sir, thank you po.
Okay. Other questions before we wrap up this particular session?
Wala na po, sir.
Sige. So what I'm gonna ask later on is, so please submit a list of your group mates, and also indicate your leader para sa ating alternative assessment. And please stay tuned for further clarifications regarding the formative assessment sa ating GC. So with that, I thank you for your participation in today's session. So I hope that we've learned something for today. So in the meantime, so please enjoy the rest of your week and stay safe always. And I hope to see you again next week.
Bye po, sir. Thank you po.
Bye po, sir. Thank you
Thank you po, sir.
Sige, sir.
Bye po sir, thank you po.